Hello, this is assignment 25 of the STEP support programme. You'll notice that this assignment is all about integration. There's lots of questions about integration by substitution, and then this is the STEP question on that assignment. So there are basically three bits of the STEP question. There's a part which tells you which change of variable it wants you to do, and then there's two other parts. And we are fairly sure that there's going to be some sort of linkage here, especially as these all involve a log function. So there's probably some sort of connection between the three. Okay, so for the first part, it tells you what change of variable to use. So let's start by using that. So we've got the integral from 0 to pi by 4 of log 1 plus tan theta d theta. And I'm going to start by calling this I for the integral that we want to find out. And it'll become apparent why I'm doing that as we go through the question. Using the change of variable, when theta equals 0, we need phi to equal pi by 4. And when theta equals pi by 4, we need phi to be 0. So we've got that. Tan pi by 4 minus phi. And then when we work out here, we know that d theta by d phi is minus 1. So this is multiplied by minus 1 d phi. Okay, we've got a negative 1 here. And we've got some limits. And we can use that negative 1 to flip the limits over. So now we're going to go from 0 to pi by 4. And then in here, we can use the tan addition formula. So this is tan pi by 4 minus tan phi all over 1 plus tan pi by 4 multiplied by tan phi. So that's using the addition formula on tan of a minus b. Okay, we can simplify this a bit because we actually know what tan pi by 4 is. Tan pi by 4 is equal to 1. So this is 1 plus 1 minus tan phi over 1 plus tan phi d phi. And then we can write all of this over one fraction. So this is 1 plus tan phi plus 1 minus tan phi all over 1 plus tan phi. Let's do that one. Okay, so we seem to be making relatively good progress. These tan phi's cancel. So we've now got, just going to write it over here, integral 0 to pi by 4 log 2 over 1 plus tan phi d phi, which is equal to 0 to pi by 2 log 2 minus, so I'm going to use the fact that log of a over b is the same as log a minus log b. Oh, why have I put pi over 2? That's pi over 4 still. Minus log of 1 plus tan phi d phi. So that is equal to 0 over pi by 4 of log 2 d phi minus integral of 0 pi by 4 log of 1 plus tan phi d phi. And what you should notice now is that this part here is exactly the same as this part here, apart from instead of the dummy variable being theta, the dummy variable is now phi. So this is equal to integral 0 to pi by 4 log 2 d phi minus I. Okay, so that's been quite a few lines of working. When you're working on A4 paper, you can just keep going down. Let's just finish off in this box over here. So therefore, we have I equals the integral from 0 pi by 4 of log 2 d phi minus I. So then you can take both of these i's over to the same side. So we get 2I is equal to this integral. So therefore, I is equal to a half of the integral between 0 and pi by 4 log 2 d phi. So all we need to do now is do that integral. One of the things to remember is that log 2 is just a constant. So it's a bit like integrating with 5. So when you integrate a constant, we're going to get log 2 multiplied by phi to 0 and pi by 4. So this is a half log 2 times pi, phi is pi by 4 minus log 2 times 0, which is 0. So this equals pi over 8 times log 2, which is what we wanted. So we've now done that first part. So let's get rid of all those drawings and start thinking about the next part. So for this next part, one of the things to notice is that, well, one of the things to consider is that we would really quite like these parts to be related. That's like what happens quite a lot with step questions. It doesn't always work, but it's a fairly good first approximation. So looking at this integral here, we've got a log, but it's log of 1 plus x. Up here, we had log of 1 plus tan theta. The other thing to look at are the limits. We're going from 0 to 1, whereas up here, we're going from 0 to pi by 4. So comparing the log of 1 plus x with the log of 1 plus tan theta, and also thinking about the limits, then it might be that using a substitution of x equals tan theta might be helpful. So if you use that substitution, x of 1 plus x will become x of 1 plus tan theta, which is nice. And when x equals 1, theta equals pi by 4. So our limits are also going to match up. So that feels like it might be quite a useful substitution to do. So let's try doing that. Log of 1 plus x over 1 plus x squared dx. Okay, using the substitution, when x equals 0, theta equals 0. When x equals 1, theta equals pi by 4. This becomes log of 1 plus tan theta. Bottom becomes 1 plus tan squared theta. And then when we differentiate, we've got x equals tan x. dx by d theta is sec squared theta. Now, if you can't remember that one, well, it's a really useful one to just be able to write down, but you can use the quotient rule on sine theta over cos theta. But this is really one that is really, really useful to know. So this is going to be multiplied by sec squared theta d theta. And then we actually know that sec squared theta is the same as 1 plus tan squared theta. So if you don't know that one, we know that cos squared plus sine squared is 1. So cos squared divided by cos squared plus sine squared divided by cos squared equals 1 divided by cos squared. And then this gives me 1 plus tan squared theta equals sec squared theta. So these cancel out. So it's now become the integral from 0 to pi by 4 of log of 1 plus tan theta d theta, which we worked out here. So this is equal to 1/8 pi log 2. So that was changing the integral into something that looks very much like the one we've just done, and then the answer just drops out at the end. We might expect the next one to be slightly harder. So let's have a think about the next one. Okay, for the next one, we've already got some trig in here, and the limits this time are 0 to pi by 2, and before they were 0 to pi by 4. So what would be quite nice is if we could take the limit x equals pi by 2 and turn it into some sort of other variable where that limit becomes pi by 4. So if we actually make x equals 2u, that will change between these two limits in the way that we want, and it will leave 0 equals 0. So let's try using that and see what happens. So having a look at the limits is quite often a good way to think about what sort of substitution might be useful. Sin x, 1 plus cos x dx. Okay, so we'll make our substitution. When x equals 0, u equals 0. When x equals pi by 2, u is pi by 4. This becomes 1 plus sine 2u. This becomes 1 plus cos 2u. Dx by du is 2. So this is multiplied by 2 du. Okay. So it looks like we might have to do some more work here. It would be good if we could get a tan theta in there because we know how to integrate that. Let's start by taking that 2 out the front. Okay. I know some stuff about double angle formulae. So I'm going to write 1 plus 2 sine u cos u for the top. Okay, for the bottom, we've got a few different ones we could do. We can use 2 cos squared u minus 1. We could use 1 minus 2 sine squared. I'm going to go for the one which is cos squared u minus sine squared u. But that might not be the best one to take. I might have to change my mind. Okay, looking at this, it doesn't look very nice yet. But what we can do is we can actually rewrite the 1 in a creative way to make our life better. 1 is the same as sine squared u plus cos squared u. So I'm taking that 1 and I'm writing it as sine squared u plus cos squared u. It's an identity, we can do that. And I'm going to do the same on the bottom. Sine squared u plus cos squared u plus cos squared u minus sine squared u. And now I'm feeling that I'm quite confident that I've picked the right thing to do with cos to u, because now my sine squares cancel, and things that cancel are always nice. Okay. So the bottom we've got 2 cos squared u. On the top, we've actually got sine u plus cos u all squared. So this is a perfect square du. So I've now got that. And this is looking quite nice because I've got something squared over something squared. There's a half in there, which I don't really like, but we will just deal with that in a second. Let's get rid of some working. Let's get rid of that lot. So what can we do next? Let's keep that 2 at the front. 0 to pi by 4. We've got log of 1/2 times, and I'm going to now write the square on the outside of this bit, cos u all squared du. So that is taking the cos u sort of inside that fraction. So this is 2, 0 to pi by 4, log of 1/2. And then inside this fraction, we can actually now do some dividing. Sine u divided by cos u is tan u. Cos u divided by cos u is 1. And now I'm really looking quite happy about this because this looks a bit like that. So I think if I just do a little bit more manipulation, I can probably now complete the question. So not forgetting there's still a 2 out the front there. I'm going to split up this log. So this is log 1/2 plus, so I'm using log of a times b is log a plus log b. And then for the second part, I'm going to do 2 steps at once, which is fine as long as you're careful. Log of tan u plus 1 all squared is the same as 2 log tan u plus 1 du. So what I've done is I have split up the half times this, and I've also taken the power out. Okay, so let's split this up even further into 2 separate integrals. We've got integral from 0 to pi by 4, the pi by 4 of log a half du, remembering that log a half is just a constant like before. And then we've got 2 times 2, so that's 4 integral 0 to pi by 4 log of, I'll write it as 1 plus tan u now. So it looks even more like this previous case. Okay, I think we're in the final stretch now. So I'm going to delete a bit more working. And then let's just do the final push. We have got 2 u times a log a half. So that's integrating this first one, remembering that log a half is just a constant between 0 and pi by 4, plus 4. And then this integral here, we already know what it is because it's up here. So 4 times a half times pi times log 2. Okay, so this is 2 times pi over 4 times log a half plus 4 over 8 pi log 2. You wouldn't want to leave it like that because it looks a bit messy. So let's see what we can do to tidy it up. This is pi over 2. So I'm doing the 2 and the 4, cancelling it. Log of a half is the same as log of 2 to the minus 1. Pi over 4 is a half. This is pi. This is log 2. And then log of 2 to the minus half is minus. So taking that power outside, minus pi over 2. That should not be 4. That should be a half. Plus pi over 2 log 2 equals 0. So that feels like we've done a whole load of work to get an answer with nothing. But all of the steps there were, there are a few choices to make in places to make your life easier. Don't worry if you went the wrong way on some of them. In the end, everything cancels out and you get 0. So thank you very much, and I hope you've enjoyed working through the 25 assignments.